Question 3 has two parts. The first part asks us to show that this expression, x squared minus x plus 1, is positive for all real values of x. How do we do this? Well, there are three ways of doing it. Firstly, we can look at the discriminant, see that the discriminant is less than 0, the determinant, sorry, see that the determinant is less than 0, and that the coefficient of x squared is positive. That means that the whole thing must be greater than 0 always. Second thing we can do is we can draw the graph and find the minimum point and show that that's bigger than 0 and therefore it must always be positive. Or the third way, which is what we're going to do, is that we can complete the square. So x squared minus x plus 1, if we complete the square here, we have x minus a half squared minus a half squared, so minus a quarter, plus 1. This is equal to x take a half squared plus 3 over 4. Now, x take a half squared, this is bigger than or equal to 0. This is strictly bigger than 0. Therefore, we can say this expression is bigger than 0, and this is what we wanted to show. The second part then asks for us to show that the integral from -1 to 1 of the modulus of 2x take 1 over x squared take x plus 1 dx is equal to ln 16 over 3. Well, straight away we notice that if I differentiate, so d dx of x squared minus x plus 1 is, so differentiate this, we get 2x take 1, which is the top line. So this looks very nice for us to integrate. The problem is these modulus signs. However, that's not a problem. If we look at this, right, we know that this expression inside the modulus is positive whenever the top line is positive and negative whenever the top line is negative. How do I know this? Because the bottom line is always positive, so it doesn't affect the sign. Only the top line can affect the sign. So, when 2x take 1 is bigger than 0, that means that 2x take 1 over x squared minus x plus 1 is going to be bigger than 0. And when 2x take 1 is less than 0, that means that 2x take 1 over x squared take x plus 1 is also going to be less than 0. Well, when does this one happen? This one here happens when x is bigger than a half, and this one here happens when x is less than a half. So what do we do? Our integral from -1 to 1 of modulus 2x take 1 over x squared take x plus 1, well, we split it up into two. We take the whole interval and split it up into two subintervals. One from -1 to a half, which is going to of the same thing, and the other from a half to 1. Why do I do this? Because I know that between -1 and a half, or rather, since x is less than a half for all of this, my expression is going to be strictly less than 0. What does that mean? That means that if I look at this one, the modulus of that expression is going to be the same as multiplying that expression by -1. So I can just put a negative sign in and get rid of the modulus. What about here? Here in between a half and 1, since x is strictly bigger than a half, I know that this expression is going to be positive now all the time. So the modulus doesn't do anything, and I'm left with 2x take 1 over x squared minus x plus 1. And now I know how to integrate both of these expressions, because it's f prime of x over f of x. I'm going to use ln. So this minus sign, I'm going to bring it out the front, and we're going to get ln x squared minus x plus 1 between -1 and a half, plus ln of x squared minus x plus 1 between a half and 1. What does that give us? Well, we just substitute some values in here. So this gives us minus ln of a quarter, so substitute in a half, we get a quarter minus a half, so that's negative a quarter plus 1, so this is ln of 3 over 4, minus ln, substitute in negative 1, get 1 plus 1 plus 1, so ln 3, plus, substitute in 1, so we get 1 minus 1 plus 1, so this is going to be ln 1 minus ln, substitute in a half, we're going to get ln 3 over 4 again. Right, what does that give us? Can I scroll down at all? No, not really. Let's try. It's probably a bit too far. There we go. Okay. So for this one, okay, so now what do? We expand this out a bit. So this is the same thing as minus ln 3 over 4 plus ln 3 minus ln 3 over 4. Ln of 1, of course, is 0. What does this give us? This gives us ln of 3 minus 2 ln 3 upon 4. But I know this 2, I can bring it up to the top because of my log rule. So this is the same thing as ln of 3 minus ln of 3 over 4 squared, right? And now I know that with my log rules, a minus becomes a divide inside the logarithm. So this is ln of 3 over 3 upon 4 squared. And if we expand this out, we get ln of 16 over 3, which is what we were asked to show.